Hello, this is Dr. D, and today we are going to talk about pancreas. All right, where is the pancreas located? Very strategic position. Just as the duodenum is coming out of the stomach, right here is the tongue-like structure called the pancreas, emptying into the duodenum along with the hepatic duct. All right. Now, obviously, you know that pancreas is both exocrine and endocrine. So the hormones is not going to be released by the ducts. It is going to be released into the bloodstream. Yes. Now, the exocrine produces the digestive enzymes, which we'll talk about in Unit 4. But there are the endocrine cells, which are in the form of islets, in small islands. All right, pancreatic islets or islets, called the islets of Langerhans. You have to know this. So the endocrine part is in these groups of cells, and there are three types of cells: alpha, beta, delta. Alpha produces glucagon, beta insulin, and delta produces the somatostatin. All right, what's the function of glucagon? So here you can see the islet of Langerhans. This stimulates the liver cells to break down what? Glycogen into glucose. So you should know that glucose is the currency of the body, living body, right? Why? Because glucose is converted into ATP. Now, when you've eaten and you have lots of glucose, what does the body do? It puts it away, stores it in the liver and in the muscles in the form of glycogen. So glucagon is, it's time to encash that. When you need blood glucose is low, immediately glucagon converts liver cells. In the liver cells, it will convert the glycogen into what? Glucose, therefore raising the blood glucose level. Yeah, so it prevents hypoglycemia. All right. It stimulates what? The breakdown of fat, also to fatty acid and glycerol. That is the function of glucagon. Insulin, which is produced by the beta cells, stimulates the conversion of reverse. It is the reverse to glucagon. These are antagonistic. You understand that. This will stimulate the synthesis of what? Glycogen. So when you have eaten, blood glucose is high, you are going to store it away in the form of glycogen in the liver or in the muscles. So inhibits the formation of glucose from other non-carbohydrates. Now you can conserve your protein and you can conserve your what? Fat, right? So here helps promote and promotes the facilitated diffusion. Now, what else insulin do? Now here are the cells and with the receptor. All right. So as soon as the insulin comes and binds here, this will cause active uptake of glucose into the cell. This is going to be important. So it is going to promote the diffusion or passive transport or uptake of glucose by the cells. So what does it mean? It means if either the receptor is not present or insulin is not present, will the glucose enter? The answer is no. All right. So we'll talk about this later on. Also, insulin promotes the uptake of what? Amino acids, stimulates adipocytes, the synthesis and store fat. So you're going to store fat, you're going to conserve the fat. Okay. That's what insulin does. Oh, and we forgot to talk about somatostatin. Somatostatin, what does it do? It inhibits insulin and glycogen production. Always remember, somatostatin, you should have come across somatostatin produced by the hypothalamus. Remember, it is inhibitory. All right. So somatostatin is going to inhibit insulin and glycogen production. We are also going to talk about somatostatin in Unit 4 when it comes to digestion. All right. Now here, what we see is insulin, what does it do? Promotes the movement of glucose, right? And what does glucagon do? Movement of glycogen into the blood. And then, of course, you know that conversion of glycogen into what? Glucose. And so this is just a repetition of what we've already said. This is homeostasis. Homeostasis means how do you maintain a normal blood glucose level? This is easy. If the blood glucose drops, receptors receive that information, send it to the control center. Alpha cells secrete glucagon. Glucagon, what does it do? Break down glycogen into what? Glucose, and converts non-carbohydrates into glucose. You are trying to raise the blood glucose level, right? And blood glucose level goes up. If the blood glucose level is too high, then again the beta cells receive that, detect that, secrete insulin. What does insulin do? It will do two things: convert the stimulate formation of glycogen from glucose, store the glucose in the form of glycogen in the liver or the muscles, and move the glucose into the cell, drive the glucose into the cell. All right. So here, now we talk about the disease diabetes mellitus, which is a very, very close to my heart, because diabetes mellitus is very, very common, and it is becoming more and more common. So the word mellitus means honey. Okay, diabetes means increased urine output. We talked about diabetes insipidus in relationship to ADH. Now we're talking about diabetes mellitus, that means increased urine output because of excessive amount of sugar. Now, here, in either case, whether it's type 1 or type 2, it is hyperglycemia. That means the blood glucose level is high. Now, the type 1 and type 2 have a different reason. Type 1 appears before age 20. It's an immune disorder, all right? And here what happens is that your body attacks the pancreatic beta cells. So you will have low what? Insulin. Your insulin production is low. And you can administer insulin to control carbohydrate metabolism. Now, type 2 is the one which is not insulin dependent. And usually it is after the age of 40. Why is that happens? Because for every cell, you have to have a what? Receptor, right? So here's the insulin, here's the receptor. But what happens is, because of your lack of exercise, diet, poor diet, these receptors are going to become non-functional, or they're going to not be as receptive. Okay. So here what happens is, can the insulin bind? No, even though there's enough insulin, it is the receptors that are losing the receptivity. All right, they are not effective anymore. So as a result of which, what happens is, you will see, let me explain this. What will happen? If there's decreased insulin, there is high amount of glucose, blood glucose, yes? We talked about that, yes? We just talked about that in the last slide. If either case, insulin, what does insulin do? It will drive the glucose into the cell, right? We talked about that, right? It will promote the glucose, movement of glucose into the cell. So there's hyperglycemia. And if there's excess amount of glucose, it's increased risk. If there's excess amount of glucose in your blood, of course, there'll be excess amount of glucose will spill into your urine. And which will cause what? Polyuria, that means high urination, because water follows glucose, osmosis. And polydipsia means you'll be very, very thirsty, drinking water all the time. Now, if there's decreased glucose availability to the cell, why? Because the glucose is just not entering the cell. Okay, it's not entering the cell. In that case, the neurons are deprived of energy and they will start dying. So you will have lots of what? You will have damage to your sense organs. Okay. If they shift to the fat metabolism, why? Because now there's less glucose, so something has to replace the glucose to produce ATP. Well, what's the next thing that the body can use? Fat. So if there is shift to fat metabolism, you'll have weight loss. Definitely you'll have high ketone bodies, and that's why you'll end up with acidosis, ketoacidosis, and coma. If they shift to fat metabolism, you'll end up with either gallstones, retinopathy, liver damage, ulcer, gangrene, heart disease. This is very, very commonly seen with diabetes. All right. So this is the same thing. The pathophysiology that I have tried to explain this is the same thing. You can choose whichever one that you can look at. And I think with this, we come to an end of our presentation. I thank you for your patience listening to me. If there are questions or concerns, please come and see me. And thank you. Have a great day.